Day 90. Today we're going to be discussing solving systems of equations. Now, this is one of the more difficult topics in algebra. However, you all totally got this. The most important part about today's lesson is for you to focus on the idea that there is a solution to a system of equations. What we are doing is trying to look for the point where they cross over. This should help us whenever we're looking at it in a little bit more of an abstract way, like we do with substitution, elimination, and other things like that. Okay? So let's go ahead and jump in. So when we graph linear equations in the form of y equals mx plus b, where m is the slope and b is my y-intercept. So first thing I need to do is I need to identify my y-intercept in the equation and plot it as the point 0, comma y-intercept. Then I'm going to identify the slope in my equation and create new points. I'm going to create these new points by moving from corner to corner of the boxes, utilizing my slope. And of course, as you remember, my slope is also called rate of change, difference in y over difference in x. It also has this super crazy formula and lots of other names and different things such as rise over run. But let's go ahead and take a look at an example problem. So, first of all, here they're asking me to go ahead and graph these two. I see that these are both in standard form. I don't know how to graph stuff in standard form. So instead, what I'm going to do is I'm going to write down that first equation. I'm going to write down that second equation. And I'm going to transition them to y equals mx plus b. So how exactly do I do that? Well, first I need to identify which variable I want to isolate or get by itself. It's going to be y in this case because I want them to ultimately look like y equals mx plus b. So I went ahead and I highlight my y. I'm going to get rid of everything that's around it on the same side. And first I'm always going to get rid of whatever's not touching it. And then I get rid of whatever is touching it. This typically takes the form of exciting move, great divide. So I see here that there's an x bothering my y. So I'm going to go ahead and move this guy to the other side. All right. Now I still have a negative bothering my y. In order to get rid of it, I'm going to divide everything I see by -1. And now I have an equation. In order to verify that this equation that I've derived is exactly the same as this, I can run a linsolve, which is going to be the exact same function that I'll use to get the answer for these systems of equations. So I just want to verify that I did that correctly. Y equals x minus 5. And over here, x minus y equals positive 5. And noticing that I got a letter C, meaning this is correct or infinite solutions, but that they are the exact same equation. So I got that part correct. Let's go ahead and look at the second one. So here again, I need to go ahead and I need to isolate my y. I see I have a 3x as well as a -2 bothering it. My 3x is not attached, so I'm going to go ahead and move it to that other side. And now I'm going to go ahead and divide everything I see by the coefficient of my y. And here I have an equation. I just want to verify that I did this correctly. So let's go ahead and run a linsolve on this. So menu, algebra, solve system of linear equations. I'm going to hit OK. Let's put in that original one. Let's put in the one that we derived. And I got a C. I don't really care about the numbers and things. All I care is I see a letter C somewhere there. This tells me these are exactly the same equation. And if I was doing this with my two separate equations, and I noticed a C that would tell me infinite solutions. Infinite solutions, they're the same exact equation. All right, so I got those. Let's go ahead and get these graphed. So, first one I have is y equals x minus 5. So I'll go ahead and write that one. So first thing I'm going to do is I'm going to go ahead and look for negative 5 on my y-axis. I'm going to go ahead and make my point. And my slope is 1, meaning 1 up, 1 over. So I'll make that a little bit bigger. And I'm going to go through every single corner of the box until I run out of graph. In the opposite direction, I'm going to go 1 down, 1 to the left. All right, so I got all of those done. I'm going to go ahead and connect all these points best I can. And there's my initial line. Now I'm going to go ahead and I'm going to do my second one. Y equals 3 halves x minus 8. 3 halves x minus 8. All right, so first thing I'm going to do is I'm going to look for that negative 8 on my y-axis. It's going to be here. And my slope tells me 3 up, 2 to the right. So 3 up, 2 to the right. 3 up, 2 to the right. 3 up, 2 to the right. And I'm going to keep repeating that until I run out of graph. In the opposite direction, I'll do the opposite, but it looks like we don't even have enough space to do that. So we are done with that one. So let's go ahead and connect all these guys together. And there is my line. All right, so now I'm going to take a look at this and I'm going to decide where in the world is my solution. And it looks like they cross over right here at 6, 1. So that is it. That's my solution. This is a consistent independent with one solution. Now, of course, you guys can answer all of these questions over here. I'll just very quickly write them in. So for equation number 1, y equals x minus 5. My y-intercept was at negative 5. My slope was 1 over 1. For my second equation, it was y equals 3 halves x minus 8. Negative 8 here, and 3 over 2. And my solution was located at 6, 1. All right, let's look at the second example. So here again, they're asking me to do a very similar process. However, they are instead giving me the graphs, and I just have to decide which one is correct. Now, these are really ugly graphs and are hard to read. But what I'm going to do is I'm going to go ahead and I'm going to copy each one of these equations, and I'm going to turn them into y equals mx plus b. Oh, actually, we totally forgot to make sure that we got the correct answer here. So let's head back over to my calculator. I'm going to go ahead and run another one of those Lin solves. And I'm going to type in the two separate equations. Y equals x minus 5 and y equals 3 halves x minus 8. This is going to tell me where they intersect, if they do intersect. And look at that, exactly what we calculated utilizing the graph. All right, so for this guy, what I'm going to go ahead and do first is I'm going to highlight the variables that I'm attempting to isolate. Then I'm going to go ahead and I'm going to get started on getting them by themselves. For this guy, I'm going to move this x over. Then I'm going to go ahead, I'm going to divide everything I see by 7. Exciting move, great divide. And over here, I'll do the same thing. I'm going to move that 2x over. I don't like that negative in front of my y, so I'm going to divide everything I see by negative 1. And now I have two separate equations, which I can verify with LinSolve that these guys are going to be there. That these are correct, to verify that this and this are the same thing. So I'm going to look, and I'm looking for one that has a y-intercept of negative 18, and it looks like only b would be able to meet that, because this y-intercept is almost at negative 9. So my correct answer should be b. But how else can I verify this? Well, I can go ahead and I can do the cheat way, I can just run a linsolve on this. So let's do that. So menu, algebra, solve system of linear equations. All right, so let's type in the two original equations. And it tells me 9 comma 0, so it should be at 9 comma 0, my intersection. So I'm going to look at these, and look at that. At 9 comma 0, these guys are nowhere near, so this one is definitely incorrect. And if I look at my correct answer, look at that. They both intersect right there. So that is definitely the correct answer. Alrighty, so I want you guys to go ahead and get started on your example question, and I will see you next time.